This complex number session 26, we are going to see about application of De Morgan's theorem, part 3. Already we have seen in the part 1 how to simplify for cos theta plus I sin theta the whole power n, and for sin theta plus I sin theta the whole power n. And in the part 2 we covered how to simplify 1 plus cos k theta plus I sin k theta the whole power n and similar model. And in this part 3 we are going to see how to simplify a plus ib the whole power n plus a minus ib the whole power n. Let's go into the problem. This is what our main goal, how to simplify a plus ib the whole power n plus a minus ib the whole power n. First of all, to simplify this, we have to convert this complex number into its polar form. So that, let us do a thing. We have to treat this complex number, whether this a plus ib or a minus ib, whatever it may be. First we are going to select this complex number, and we have to choose this complex number. We have to name this complex number by the name z, and we have to convert it into polar form. How to convert it into polar form? To convert a complex number into its polar form, first of all we need its modulus. Modulus is nothing but r. So first we have to find r value. R is nothing but square root of real part square plus imaginary part square. So r is equal to square root of a square plus b square. It's very simple. After finding the modulus, we have to find argument. To find argument, we have the formula, that is theta is equal to tan inverse of b by e. Anyhow, we cannot find it very easily. To get the actual exact theta, we need two things. One is table and another one is a graph. That is, after finding this numeric value, whether we are getting the answer in positive or in the negative, treat that as positive and go to the table. From this table, we can get the angle. After that, we have to follow the graph as follows. This is what that sheet. Now we have to see whether the real part is positive or negative, and we have to see whether the imaginary part is positive or negative, and we have to find in which quadrant this particular complex number lies. In case if it lies here, we have to follow the formula pi minus theta. If it lies here, we have to follow the formula minus theta. Like that we have to do for these two quadrants also. So after finding the angle from this table, just treat that angle as theta and follow this graph. If it is in the first quadrant, keep the answer as the same. If it is in the second quadrant, we have to do pi minus theta. This theta is the angle obtained from this table. So this is what we have to follow. So now we know what is r value and what is the real value of theta. After finding these two, we have to apply this formula. A plus ib is equal to r into cos theta plus I sin theta. All these things already you have learned. If you have doubt, you can see complex numbers polar form 2. If you see that video, you can understand it very deeply. Now let us dive into a problem. Let us see a problem. That is 1 plus I root 3 the whole power n plus 1 minus I root 3 the whole power n. We are going to simplify this problem. First, as I told you, let us consider, or let us take this complex number, that is 1 plus I root 3. After that, after completing this, let us go to the next complex number. First, let us take this 1 plus I root 3 the complex number, and let us try to convert it into polar form. Right. This is what our complex number now, that is 1 plus I root 3. If we take modulus, that is r, it is nothing but root of a square plus b square, that is square root of real part square plus imaginary part square. Here our a value is 1 and our b value is root 3. if we substitute it here, we'll get the answer square root of 1 square plus root 3 the whole square. Square and root cancelling one another, so our answer will be 1 plus 3, that is square root of 4. Our answer will be equal to 2. So now we got the answer for modulus. Now we have to move to find the angle or the argument. How to find the angle or the argument? The formula is theta is equal to tan inverse of b by a. So our b value is root 3 and our a value is 1. So if we apply it, our answer will be tan inverse of root 3 by 1. That if we simplify it, we'll get the answer as tan inverse of root 3. Now the answer inside this is positive. Even though if you get answer as negative, don't consider the negativity, just take only the positive value in your mind. We have to take like that. So after considering this as a positive, now it is positive. Even though if it is negative, yeah, we have to consider this as positive and we have to go to this table. Now it is given tan inverse of root 3. Root 3 by 1 is root 3. Now let's see tan and for root 3. So the answer is 60 degree. That's good. So this angle should be considered in our mind. But we cannot write this 60 as it is here. Before writing this, we have to follow the following graph. See this procedure. Now, if you see here, this is our real part, it is in positive. This is our imaginary part, this is also in positive. So we have to find in which quadrant it lies. Both are positive. Real is also positive, imaginary is also positive. So the answer says theta. That means we have to write the angle as it is. That is, our answer is 60 degree. So our theta is 60 degree. Now let us try to convert this angle into radian, from degree to radian. So our theta will be equal to 60 degree, that is equal to pi by 3. So the real angle is pi by 3. Now you know what is r value as well as what is theta value. To convert a complex number into its polar form, we have a formula a plus ib is equal to r into cos theta plus I sin theta. Now if we substitute r value and theta value, now the complex number will be converting to its polar form. So 1 plus I root 3 can be written as 2 into, that is r value, cos of theta is pi by 3 plus I sin theta is pi by 3. So this is what the conversion of this complex number into its polar form. So our first work is over. We have converted this complex number into its polar form. Now let us go to the next complex number, that is 1 minus I root 3. If we try to convert this 1 minus I root 3 into its polar form, as usual we have to find r value. We'll get the answer as 2. It's very simple. If we try to find theta value, tan inverse of b by a, our a value is 1 and b value is root 3, that is minus root 3. So if we substitute it, our answer will be tan inverse of minus root 3 by 1. So that is tan inverse of minus root 3. As I told you, even though if you get a negative number, treat this as positive in your mind and go to the trigonometric table. So if you go to tan inverse of root 3, it is here. This is what that value. And the respective angle is 60 degree. This is here. So answer is 60 degree. But we cannot write this 60 degree as our answer here. As I told you, keep this in your mind as theta. But follow the following graph. This is what our graph. Now we have to see where this complex number lies, whether in the first quadrant or in the second quadrant or in the third quadrant or in the fourth quadrant. Here the real value is positive but the imaginary value is negative. So we have to choose real positive, imaginary negative, real positive and imaginary negative. So it lies in this fourth quadrant. Formula says then we have to apply the value of the angle is minus theta. So now we have to find minus theta. We have considered that theta is 60. So our minus theta will be equal to minus 60. That is nothing but minus pi by 3. Since pi is 180, 180 by 3 is 60 degree. So now the angle is minus 60 degree, that is converted into radian, that is minus pi by 3. Now we know the real r value as well as the angle. Let us convert this 1 minus I root 3 into its polar form. So 1 minus I root 3 will be equal to 2 into cos of minus pi by 3 plus I into sine of minus pi by 3. Cos of minus theta is nothing but cos theta, and sine of minus theta is nothing but minus sine theta. So for cos of minus theta, for cos of minus pi by 3, we can write that as cos of pi by 3. For sine of minus pi by 3, we can write that as minus sine of pi by 3. So 1 minus I root 3 will be equal to 2 into cos pi by 3 minus I sine pi by 3. Now we have converted the second complex number also into its polar form. Now let us try to simplify the problem. The problem is 1 plus I root 3 the whole power n plus 1 minus I root 3 the whole power n. 1 plus I root 3's polar form is 2 into cos pi by 3 plus I sin pi by 3. 1 minus I root 3's polar form is 2 into cos of pi by 3 minus I sin of pi by 3. So if you try to find 1 plus I root 3 the whole power n plus 1 minus I root 3 the whole power n, that will be equal to, instead of this we have to write 2 into cos pi by 3 plus I sin pi by 3 the whole power n plus, for this plus, instead of 1 minus I root 3 we have to write 2 into cos of pi by 3 minus I sin pi by 3. So it's here. For this whole power n we have whole power n. Now this power n is for this 2 as well as for this bracket. The same way here also. So our next work will be 2 power n into cos pi by 3 plus I sin pi by 3 the whole power n plus 2 power n into cos pi by 3 minus I sin pi by 3 the whole power n. Now we can apply De Morgan's theorem, because to apply De Morgan's theorem in the real part we must have cos and in the imaginary part we must have sine. Here also we have the same way. Moreover, the angles should be equal to one another. Here pi by 3 that is equal to pi by 3. So we can apply De Morgan's to this. Also to this. Now according to the De Morgan's theorem we have to just bring this power as number value to the angle. So if we bring this n inside this, we'll get the answer as 2 power n into cos n pi by 3 plus I sin n pi by 3. The same way 2 power n into cos n pi by 3 minus I sin n pi by 3. It's wrong. It's an error here. Minus I sin n pi by 3. Now if we take 2 power n commonly outside, our result will be cos n pi by 3 plus I sin n pi by 3 plus cos n pi by 3. This is minus, as I told you, minus I sin n pi by 3. So these two terms will be cancelling one another. Our result will be this cos and this cos. So 2 cos of n pi by 3. So the answer is 2 power n into 2 cos of n pi by 3. So 2 is nothing but 2 power 1. So the formula will be a power m into a power n model, that is a power m plus n. So the result will be 2 power n plus 1 into cos n pi by 3. So it's very simple. Now we have simplified the problem. The same way we can do so many sums. Just you try the same sum with a small change, 1 plus I root 3 the whole power n minus 1 minus I root 3 the whole power n, and check the result. Moreover, try to solve many problems from your textbook. Thank you.